So here's what I mean by all realities have to agree despite time dilation. There's a thought experiment, the train guillotine thought experiment. A train is going through a tunnel and there are guillotines on either end of the tunnel. As the train nears the speed of light, length contraction happens and the train can fit inside the tunnel. The two guillotines go down and up and the train isn't chopped up. But that's from our perspective. What about from the train's perspective, which is going to look normal to it? Well, for the train, one side of the train is going to enter the tunnel, then a guillotine's going to come down, then it's going to come up, then it's going to exit the tunnel, then the other guillotine's going to come down, and then it's going to come up. We are seeing different parts of the train enter and exit this tunnel at different points in time, but the same thing has happened. The atoms and molecules in this train have entered the tunnel, have seen a guillotine go down, seen it come up, and exited the tunnel. This train has done the same thing. The same events are happening, the only thing that is different is how we see them in time. Now, this brings us back to the whole no time passes for a photon thing. All space-time can be described with a coordinate system, 3 coordinates of space, 1 coordinate of time. So when you say a photon experiences no time, you say that it experiences the point of its origin, the point of its destination, and all points in between at the same time. If that were true from the photon's perspective, if that were true, then if we put a detector that would absorb that photon in its path, the detector should detect that photon and it should still arrive at its destination because the photon exists at the detector's point and the destination point at the same time. But that is not what happens. If the photon hits the detector, its journey stops. This is an experiment that we can actually do, which means that if the photon actually experienced no time, if the photon did exist at every point of its journey all at the same time, that our realities wouldn't agree. And one of the things we need to do is make realities agree. In relativity, realities still agree, even if our perception of them, even if our time perception of them disagree. Therefore, we see a photon at one coordinate in time, and then another, and then another, and then another. We see time pass for that photon. While time may pass differently for that photon, remember photons don't have perspectives, but we're just kind of playing devil advocate here. While time may pass differently for it, it can't pass in a way that makes realities disagree. And experiencing no time would make physical realities disagree, so that can't be the case. Thus, photons do experience time.